Alright, take it back to basics. It's Trane again. Yeah, so this unit, first of all, this building is a cinder block building with, they have metal framing and the roof section. They have foam, and then after the foam, they put a membrane over it to, prevent the water from going on the inside. But these units, what they did, when they do construction and everything, each one of these, they follow the plans, they cut the holes out in the metal, the metal roofing, and then they create a curb. So all of these units, they have a standard curb. So the curb is the section coming. So this is a flooring, and then this is just like the curb section to sit the curb adapter on. So the curb adapter, the unit is sitting on the curb adapter. So you have the curb, and then somebody designed the curb adapter with the dimensions of the curb itself, and then get the dimensions of the unit, and they make a sheet metal adapter so the unit can fit on there. And then what they basically do is you have a supply and a return plenum section. So you have a supply ductwork that goes down, return ductwork that goes down. A lot of people, they use metal depending on the application. So you have metal, or you have fiberboard. Fiberboard is flexible one, metal is much hard. But if you even use the sheet metal, you still have to insulate it, especially if you're in a high humidity area. That unit can sweat and have a lot of water in the building, like dropping on the ceiling and messing up a lot of stuff. So in the high humidity area, they use insulation on whether it's ductboard or metal. So I'm gonna be going over the basic of these units right now for you. So this is a Trane package unit. So basically, this is what's going on in here. Right? I'll show you what's going on. So the power comes up, boom, hit this breaker right here. Right? And this is a 15 amp breaker. Power coming in from there, it goes over into the heater section. From the heater section, so this is the heater section right here. Open up here. Low heater section. That's high voltage. That's 460 volts. So you don't want to touch that. And right now the unit is live. So sometimes when you're doing the testing or maintenance, you have to check the unit for amperage and all that stuff to make sure it's not over-ramping and causing any issues. So those are the heater kit. That's the heater kit up there, and that's a 3-phase heater kit. So a 6 kilowatt 460 volt, and then you have a contactor that actually controls the heater. So that's operating. You have high voltage on one side, and the low voltage is what when they call for heat, it just throws that contactor over there, and the contactor comes on, come on and heat the space. All right. So this, you have the LTB boards, one the test board, and the other one, you have the CO2 sensors, humidity, and all that stuff. So all of these wires, they're connected together on the low voltage side, where you can put the unit into test from here by jumping out test 1, test 2, depending on how long you hold the jumper on that wire. Those wires is gonna actually put the unit into test, whether it's gonna be cool 1, cool 2, heat, dehumidification, and all that stuff. So this is a transformer that's converting high voltage to the low voltage to give 24 volt to control this contactor, which is the compressor contactor, and that contactor right there is a blower contactor. And all of those, you have to have low voltage to actually operate them. And this board actually have a communication board from Trane. So this communication board, it just have these wires right here, which those wires, they're daisy chain between each one of these units on the roof, and then each board has its own address. So when it's daisy chain to each unit, it's going back downstairs to the supervisory controller, where you can log into the computer and see each unit. Each unit have to have its own address. So, you know, this communication board is different from the one I was showing from the AN unit. So that's a different thing. So what's actually controlling the unit, this is a RTRM board. The RTRM board, all the low voltage have to go through here to operate this unit. If this goes bad, the unit's not going to operate. So this board, you can have communication on here, or you can have an actual thermostat that you install in it. Move this out of the way. Somebody install something and just leave it. Alright. So on here you can see these terminals. There are different components that can be connected to this board. So because we're using the Trane communication board, you know, when you log into it, you can see everything that's going on the unit. So on this board you have sensors and all different type of stuff on there. So this is a outside air sensor, a temperature sensor, and then you have an indoor temperature sensor. You have, this is the supply and the return sensor wires. So, you know, when you log into the system, you're gonna see, you know, what the temperature of the unit and the space temperature and all that stuff, and then it goes from there, you know. So that's the basic where the low voltage is concerned. And the high voltage, as I said, that's the contactor for the compressor. This right here is a compressor. So the compressor works with the condenser. The condenser, that's, you know, that's like copper coils with fins, and then that's the condenser fan motor. Inside here, you know, let me shut down this unit real quick. Unit is dead. So this is the blower compartment, right? So this blower actually have a blower wheel, the blower motor, which is still high voltage, a belt that runs it, and the evaporator coil. See, all these coils are connected through copper piping. And the pipe runs here, goes to the compressor. From the compressor, you have a valve there, which they use it as a reheat valve. Some people call it a reversing valve. Basically, sending in the liquid from the inside to the outside, from the outside to the inside, basically. So this is the actual outdoor coil, compressor and everything. All of these works together. Where the compressor pump, you know, the gas from here, you know, it goes to the condenser. The gas goes to the condenser. It condenses. It goes to the TXV. The TXV on the inside, which this is the TXV right here. The TXV, you know, flash that liquid, and you know, it makes the components inside, like the bubbles and everything, expand. And then when it expand here, it start flashing it and send small amount of, you know, a vapor and a liquid mixture down here. And by the time this liquid goes through the coil and the condenser, you know, when the fan spins, it pulls the air from the inside. So that's a return. It pulls the air from the inside, sending the heat across that coil and boiling that refrigerant. When it boils the refrigerant, it gets cold. That air is then pulled from that and it's pushing into the building, and that's how you cool the space. And then this board, you know, show the temperature and everything on the inside, and this controller, you know, sends, you know, whether the unit is satisfied or you need heat, you need cool, but they can monitor everything from this board going on the inside on their EMS system. So that's basically what's going on this unit. It's not too complicated, but you know, I have Mike over there pressure washing the coils and pressure washing everything. He do a good job. So we're gonna go through and check every single one of these units. You know, we're gonna check the belt, we're gonna check all the wiring, we're gonna make sure the unit is working good so the customer can always have cool. All right, thank you for the support. And then, you know, if you follow me, I'll show you step by step on each unit, so at least, you know, the young technicians that want to go in the field, you can see what you're getting into. You know, it's decent money, you know, and later on you can, you know, run your own business as well. So I don't really have a problem sharing my knowledge. That's what we're here for. All right, thank you very much.